Good morning, everybody. I'm Dirk van Thiel, doctor in human-centered AI and co-founder and CEO of AdviceRobo, and non-executive director with IKEA Bank in Europe. And I'm happy to present to you this morning because we are standing at a pivotal moment in the evolution of credit, a shift from cold scores to real human understanding. That's why I want to welcome you to our journey beyond the score, when we infuse human intelligence into digital decision-making. Let's explore a future where platforms and credit bureaus don't just predict risk, but understand and help people. But before I start, I want to ask you a question because I'm curious about your thinking. We talk a lot about risks and protection these days, and that's logical. But when the evolvement of data and AI in scoring systems is actually happening, where do you guys see the biggest opportunities? You can just shout if you have any idea. Any opportunities from the evolution of data and AI as we see it currently? Financial inclusion, yes. Big one. Cross-border trade, we just discussed it this morning, yes. Happiness, more people with a smile. Yeah. Okay, well, that's the reason that we are doing what we're doing. So here's the journey we'll take in this presentation, understanding the challenge of the unseen, because that's what we do. We'll begin with who we are quickly, AdviceRobo, then we move into what we see as the challenge in this world, to drive the transformation, our solution, which we call human-centered AI, and then we'll move into real-world use cases that show that this isn't theory, but that it's actually happening. So, billions of people and businesses today are invisible to traditional credit scoring. And that's not just a data issue. We thought that when we started, but it's more like a human gap. It's a way of looking at things and looking differently at things. So that's what we do with AdviceRobo. AdviceRobo was founded to solve a massive global issue. Billions of people are credit invisible. And we use AI not to replace humans, but to understand them, making decisioning systems and credit scores inclusive, fairer, and smarter. We are doing this since 2013, so for over a decade already. We scaled our company to 13 countries currently. We also work in Asia, in Japan, Vietnam, and with a profit last year of 8 million, we are world's largest alternative credit scoring company at the moment. At the platform, we see that the benefits for our customers are very simple. In essence, our customers are able to accept 30% more people with a smile, at a 20% lower default rate. That's what it is. We are used by retailers, neobanks, credit bureaus, and we have offices in several countries across the world. We started this journey by pioneering micro-personalization because we don't believe that people and scoring of people is about averages. It's about personalization. It's about real understanding who the person is and in what context this person lives and makes decisions. At the heart of our solution is our platform that we've been developing over the past decade. On the left side, you see a lot of data sources. We generate proprietary data in what we call JAC, the Joint Assessment of Credit Quality software tool that our customers place in their application processes or in other customer touchpoints. And we enrich that with other data, usually local data that makes the scoring better applicable in the tailored situation. In the platform, we work with a lot of scoring mechanisms, scoring APIs, data pipelines to prepare all the data and clean it for scoring. And at the other side, in pink, you see the output. It's credit profiles, it's fraud profiles, credit scores, fraud scores. And we also heard this morning about helping people with micro-personalized campaigning, helping them to build credit, helping to build credit worthiness, and helping them to build financial health. Our innovation is driven from our AdviceRobo labs, our human-centered AI labs. We have a rich ecosystem of universities across the world, where we continuously research actually in 3 areas of direction. First, of course, is continuously research new data sources. Every quarter, we launch a new data source in our risk decisioning engine. And last quarter, we, for example, launched smartwatch data to predict credit risk. The second area of innovation and research is in privacy-preserving technologies, areas like synthetic data, federated learning, that are very crucial in sharing data between companies, sharing data across countries, but also in making the data processing much more efficient. And the last area of research, of course, is large language modeling for driving the micro-personalization campaigns. So for us, AI isn't about artificial. It's about applied intelligence. It's about applying intelligence in real-world situations where it really is required to make better decisions that help people. So our platform solutions are very simple. Our customers use our synthetic data lakes to share data, to advance their pre-processing and processing of data. They use our data itself, which I'll come back later on. They use our scoring models, which we call AI advisors. And of course, we have some large customers that use our technologies for building intelligent agents that really solve parts of the customer digitalization and lending process. So now to the challenge. The challenge is what we see, that traditional credit scoring isn't fit, although we had a lot of benefit from it over the past decades, but it isn't fit for the current complexity of this world. We see different things happening. We see a shifting customer demographics. A lot of younger people, next-gen people, that have different demands for customer experience, for using credit, and also using finance anyway. We see increasing regulatory compliance demands. We are from Europe, the world's most regulated continent, and we are not very proud of that, I must say, but it is a fact. But also over here and in Latin America, where we have ventures, there's a lot of regulation, and that drives costs. In the bank where I'm a non-executive director, it's 20% of the operational costs already. We see persistent risk factors, trade wars, economic volatility, high inflation rates. Also over here in Malaysia, higher taxes to make a middle class, but it all eats the affordability of people. And then in all this complexity, it's our task to drive innovation. And that makes it really difficult. And that also asks for a different approach, for more agile innovation approaches. Coming back to where I started, traditional credit scores, which usually are logistic regressions with 12 to 15 variables at the most, cannot capture this complexity. Therefore, you need to switch to a different scoring methodology, and that's what AI offers. Let me give you some examples from how we started. At Firestorm, we started because of our own frustration. In 2013, we started this company. In 2015, our first product, which was a psychometric credit score, was ready to scale to the United Kingdom. And although I was a former banker and my co-founder also was a former banker, we were both from the board of ING in Europe, no bank wanted to support us in scaling this company. Even worse, we sold our first fintech a half a year before we wanted to scale. And even with that success rate, banks didn't want to score us. The reason why is we didn't fit the traditional financial ratios. So that brought us to the insight that we had to look different at people and at entrepreneurs. Like us, startups, small businesses, what we were a decade ago, there are 360 million MSMEs in this world, 70 million in Asia and 73 million in India. But it's not only about small businesses. It's also about consumers. I told you we work in Vietnam. This is Tran Minh. He's a taxi driver in Hanoi. He's married, has one son, and works irregular hours as a taxi driver. So he's self-employed. And you guess already, Tran got a car incident, and now his taxi broke down. And he's got no savings to cover for the expenses. But also in this case, because Tran has no fixed income, traditional scores and traditional banks are not able to help Tran. Like Tran, there are 40% of the population globally is self-employed currently, 270 million people, and 50% of the population over here in Asia. Another example, the last one, Maria Cruz Santos from the Philippines. She works also irregular hours. She works as a waitress, and she actually has the same issues as Tran. In her case, one of her children got ill, and she's got no savings to cover for the medical expenses. And again, traditional scores, traditional banks are not able to help Maria. Again, because she doesn't fit the traditional financial ratio models. So I mentioned we came to the conclusion that we had to look differently at people and at entrepreneurs. And then when I studied that, I discovered that there's another reason to do that. That's because we are in an evolution of banking. We are all automating for efficiency. But what we are looking at is a transformation from banking 3.0 to 4.0 to 5.0, where automation is not anymore about efficiency, but about empathy. It's about hyper-personalization and driving inclusivity. So that's another reason why human-centered AI, in our opinion, is key for driving these transformations. So how does the solution look like? Most credit bureaus, at least the larger ones, and we work a lot with large credit bureaus, automate currently their processes in what they call decision platforms. We see the Experian Power Curve, for example, and it are platforms like this, where they organize data management, analytics, identity delivery, and offer modules to their customers that they can easily use. This automation is an automation of efficiency. In that, and that's a major issue, and that's also why we work with a lot of credit bureaus, we see that they still rely on the old way of modeling. But like I said, these models are not able to cope with the complexity of this world because they are data poor, they're very much biased, they only look at the thick file customers, and they have an outdated logic. What we need is data-rich, accurate, and more instant AI logic that continuously also improves the scores when behavior happens. Our approach is based on human-centered data. That's what we presented in JAC. Our data starts with product data, applicant data that we receive from our customers, and enrich it with psychometric data, biometric data, and really a lot of digital footprint data. You can imagine that's the source that is transforming this world currently. Over here you see, however, that digital footprint data is currently, the current moment in time, the least predictive of the data sources. Let me first look and dive a little bit into the psychometric part, because psychometric is really powerful, but also the way it's been offered in the current markets is really old-fashioned. Psychometrics started a decade ago, in the 1920s, when Jung started asking questionnaires to his patients and came up with what we now know as the MBTI model. The MBTI model is used for recruitment, personal development, but also for team building. And it defines typologies of people. Then in the second half of last century, a group of scientists wanted to make something more scientific out of psychometrics. And they came up with the OCEAN model, which stands for openness, consciousness, extroversion, agreeableness, and neuroticism, what they call the big 5 personality traits. So the model already says it, it's an evolution from types to traits. The big 5 personality traits also are used often in recruitment, psychology, but also in business, market segmentation, and in 2012, for the first time, also in credit decisioning. The downside of this approach is that the predictiveness is questionable. It's a Gini of maximum 0.4. And, well, the worst thing is you need to answer about 80 questions to come to these kind of insights. So it doesn't work for the next generations. It doesn't work in the grab apps and in the touch and goes. That's why we decided to make a new approach, where we combine the best of psychometrics with behavioral economic insights. We look at someone's overconfidence, very important for the risk prediction of entrepreneurs, financial self-control, mental accounting, risk tolerance. And the drivers in a model eventually, they're presented in the middle, became financial skills. So how financially skilled is someone or an entrepreneur? What's his level of self-efficacy? How much is he in control of the things he does? How does he think about debt? Is debt a normal thing in life? Or is it something to be afraid of? A lot of young people are afraid of debt. Materialism, if you earn money, do you spend it directly in expensive cars and other things, or are you able to save? Gratification, which is another word for impulse buying tendency. Fluid intelligence, also an important driver for entrepreneurs. Only for entrepreneurs, for consumers it doesn't work. And social desirability, that's the openness to other opinions. This model, which also started, of course, with questionnaires a decade ago, has a Gini between 0.6 and 0.8. So it's a huge improvement versus the ocean model. And over the past decade, we transformed the questionnaires into digital data. So this approach, which is captured in Jack, is instant and provides instant profiles of someone's psychometrics profiles. Then the insights are translated into a score between 0 and 1,000. The closer to 1,000, the lower the risk. And on the right side, you see that the score does not only work on psychometrics, but also on biometrics. So we also look at how people interact with the touch points, the digital touch points that they use with their mobile phone or their computer. And then when you have captured the data, the real science happens. So this is what happens in the platform. You see 3 risk plots. The left one is a generic one. Red in the risk plot is risky applicants, people you should reject. Green is acceptable. You can accept these people. And the star in the plot is someone who applies for a loan, in this case for a credit card. And this is a Manuel, this is a Tran or a Maria, or a Diederik a decade ago. This is a person without a fixed income that doesn't fit the traditional risk models. Then what happens with traditional risk modeling is what you see presented in the middle. We all apply logistic regressions, and you have to end up in between the lines to be accepted. There are 2 issues. You can see that directly. There's a lot of red in between the lines, the false positives, people we have accepted, but we should have actually rejected them. But even worse, there's a lot of green outside, the false negatives, people we could have accepted, but we rejected them. What our platform now does in our approach of human-centered AI is what you see presented on the right. So with all this new data and with the application of AI, we use tree-based models because things have to be explainable. We present what you see on the right graph, and that's a much more granular description of the risk. And this enables our customers to accept 30% more people at a 20% lower risk because the traditional risks are also carved out. So our journey beyond the score is a journey in discovering other data sources. Data sources like psychometric, where we started with, enriching it with biometrics, digital footprint. We work with mobile data, of course, in countries where that's allowed. It's not allowed in Europe still, but in a lot of other countries it is allowed. Email reputation data, and in essence, we profile people on both their affordability and their behavioral stability and the willingness to pay. And our customers make strategies on these insights. From the platform, we offer different type of solutions, different type of scoring solutions. We have customers who only use the data, but we have also customers who only use the psychometrics, for example, especially in Latin America. It's very, very much liked. We have a fraud scores based on all this data, and we also now move into lead generation because we can help our customers find credit-worthy customers in the near prime and even the subprime segments. Not always in the subprime, but anyways in the near prime. So the scoring and the solutions can be applied not only in the onboarding decision, but across the full credit life cycle, from targeting to even win-backs and collections. In essence, we have been doing the same as the credit bureaus. The only difference is that we came from the other side. We automated empathy. We automated human intelligence. And actually, you can plug it on top of it, the traditional platforms, and enrich it with it. So these kind of solutions help to solve the gaps that we see in the world. The inclusivity gap, the agility gap, but also the insight gap. And we see these gaps as opportunities to help more people and help them responsibly. Now let me show you a few use cases. This is a European one from the United Kingdom. One of our first customers, and still very active, New Day, a credit card company, focuses on students and first-time workers who have not been able to build a credit score or a credit profile in the United Kingdom. So with our data and with both our teams, we developed a modeling approach for them that they are still using. This is a use case from Turkey, where we work with the Turkish credit bureau, KKB. KKB is the only credit bureau in Turkey. We have found a customer, this also almost a decade ago, BNP Paribas, where we were part of their acceleration program in 2018. And one of their daughters, STEP in Turkey, wanted to drive financial inclusion of young urban professionals. That was the first target segment they had. And through KKB, through injecting our scores in the KKB scores, they are now able to do that. A use case from Latin America. The International Credit Bureau in this case is Experian, where we also plugged into the Power Curve platform. And Mundo Total is a large retailer from Colombia. And we offer, together with the credit bureau, responsible by Now Pay Later solutions in store to these kind of iPad silos. And the last one is about synthetic data. This is a neobank, a large European neobank. They use our synthetic data lake to scale across countries. So any time that they want to move into a new country, they want to scale from the Netherlands to Germany, to France, to Italy, they have a lack of data, they have a lack of models. And with our data lake, they are able to launch in 3 months' time, where they before needed almost a year to test and train the models and validate them. So this is about efficiency. So to finish off, in short, human-centered AI is about scoring the unscorable. But not only that, also with thick file customers, we see that deeper profiles have a lot of benefits, and that's also why the credit bureaus in Latin America and in Turkey use us. It enables you to detect early warning signs of fraud and default because it's dynamic data that we use. It's not a static photo. You continuously monitor the behavior of people and see if things happen in their life that indicate fraud or potential default. And like I said, the major benefit that our customers see is that they experience increased approval rates with behavioral explainability. So I want to thank you very much. For us, this mission about human-centered AI is not an advanced robot mission. It's a mission of doing it together with the companies that are present in the markets. So if you're interested in further discovering how this works, if this data enables you to increase the performance of your, for example, cross-border applications, we are open for a lot of types of corporations. And for now, I want to thank you very much for your attention.
Any questions, Diedrich? A lot of jargon in there, and a lot of, but it's I got it, I followed it. So, one question. Let me give you the awkward question back. From earlier. I mean, the biggest problem always used to be a perceived problem was the explainability, isn't it?
Yeah.
So, you know, that's why a lot of people try to use psychometric, but just couldn't explain it when you say. I mean, it's okay when you say yes, but when you say no, that's the big problem, isn't it? So, I was intrigued about the explainability bit at the end there. So how are you getting around that? How do you, so if I'm a consumer and I'm get rejected, and I come to the bureau says, well, it's not your score, but it's this. How do you explain it?
Yeah, that's a good question, which we continuously also get, of course,
I'm sure.
especially in Europe. So in the development of this, we work a lot in cooperation with the FCA. The FCA has a sandbox tool which is digital. You can program your API against that. There are 1 million British people behind that, and then you are able to test the things you do. And then the FCA starts asking you questions like this. So how do you explain that person A is not accepted and person B is? It's in the behavioral profiles that we find the explanation. So it's not about the affordability as such only, but it's also about risky behaviors. Like, is this, for example, is this entrepreneur buying a lot of material, expensive goods when he earns money? That's a risk indicator. With biometrics, if people hesitate too long when they go through, for example, an application process, that's a fraud indicator. So that's how we can prove it on the millions of use cases. So together with the FCA, we found how to answer these kind of questions and how to also prove that it's a correct answer.
I presume that Generation Z would probably be okay to discuss that, aren't they? I suppose the older generation probably just wouldn't be. But you have a question, I think. Just name and organisation, please. Are we good?
I think it's working, yeah. Hi, this is Stephen from Island Credit Solution, Philippines. And as a credit bureau, we always have been asked by our customers certain questions. And I think you mentioned the psychometric data is very powerful and predictable. The first question is in terms of the user experience, because you need to collect the data from the user. And as you rightly mentioned, if the bank asks them for a questionnaire, then the dropout rate will be way higher than just a pure API call from there. And then the second question is, how are we able to make sure that when they answer or when we collect the data for the psychometric, or when you are using your model, they are not frauding the psychometric question. For example, they pretend they are good guys, but actually the psychometric data for the real person, it is a bad guy. So 2 questions. Number 1, how to have a seamless user experience. Number 2, how to make sure that the data about the psychometric is a real data instead of pretending they are a good person.
Yeah, very good questions. And that are also the biggest risks of the traditional psychometric approaches. Like I mentioned in my story, we managed to transform the questions into data gathering from digital footprint type of sources. And that was also a long journey. We not did this overnight. But by now we get the data from, for example, mobile behavior. And in Jack, in the tool, people allow us to access that. So it's an opt-in. People allow us to access their mobile phone or their email. And that's how we can use this digital footprint type of data to feed the models. It also feeds the biometrical models that work very well for fraud predictions. So that's how we got it seamless, actually. It's by transforming the questions, so we don't ask the questions anymore, we do it with the digital footprint, and it's opt-in, of course. And your second question was about? Yeah. 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 Yeah, it's also a good question. So that's also one of the issues we found in the evolution. And that's exactly why we decided to move into a combination of data sources. So for fraudsters, it's a combination, for example, of biometrics. but also with the email reputation data. We see if email accounts are set up recently or are in the air for a longer time. We see if they are being involved in data breaches or not. We even are able to track people back. So it's a network approach. So if they set up an email account over here and they have been, they had an email account in another country that was caught in fraud, then we also detect that. So it's a combination of the biometrics and the email-related data in this case that detects the fraud. If people don't allow us to access the email, then we are not able to score the fraud properly. Only on the biometrics it doesn't work. Well, it does work, but it's not super accurate, I must say. It only gives an indication. We need to have multiple sources to have a really accurate and predictive solution.
One question right at the back. The back on there, left-hand side. Leo, yes or no?
Hi, good morning. I'm Aizel from the Bangko Sentral ng Pilipinas, Philippine Central Bank. So this topic is very interesting, and it revolves around consumer allowing or consenting to access their information. How do you ensure that the data provided by the consumer are well taken care of?
Thank you for the question. Very good also. Yeah, that costs a lot of money. But like I said, we are European, so this is GDPR is super important in Europe. We have to comply to that, and we also comply to that. What we do is a few things. So firstly, we don't store much data of consumers. So it's a dynamic solution that scores an applicant, provides the score back to our customer, the credit bureau or a bank or a retailer, and we don't actually store the data. So we are not a traditional credit bureau that builds a database with a lot of consumers scored in it. It's an operational process that you can use to get intelligence. Our customers decide if they want to store it or not. Credit bureaus have to store it for multiple years. But that's in their environment, in their architectures. I think that's important. Then the opt-in, of course, also is important. So we also tell with the opt-in where the data is being used for. So it's not only for. So when it's a credit bureau, we say that we use it for credit score, but also that the credit bureau will store the data. And that's in Europe very important that you share that. And the only data that we store is a synthetic data, but there are no personal characteristics anymore in the synthetic data set. That's why it's synthetic. That's also what the power of the synthetic data is. So we have data sets of millions of customers which are made synthetic. That's what we store. We can use it for trading models, but without using really personal information that's traceable back to an individual. Does that answer your question? A bit, okay. Then we follow up later in the lunch break.
No, discussion over lunch. Follow it.
Hi, Val from Credit Information Corporation, Philippines also. Just curious, because for traditional financial data, they want 24 months, and they consider the last 12 months as the most useful. For alternative behavior, for your behavior model, what time horizon do you look at in terms of data freshness, usability, and for how long is it useful? Yeah. Thank you.
Also a good question. Thank you. For training the models, we train the models together with customers like New Day, like Orix in Japan, a big credit card corporation. And there we used historical data of, depends a bit on the product, on the asset class, 6 months for credit cards we did with Orix and also with New Day. For so that's what we used for training the models. in the synthetic data set is a longer history because we are in the market for a decade. We have synthetic data for 5 years now. That's 5 years of history that we have in there. Yeah, and how do you keep it fresh? I think the most important question we always get is, we talked this morning about cross-border data and cross-border solutions. The psychometrics and the biometric and digital footprint is all cross-border data. But we discovered that we need locally trained models to keep it accurate and highly predictive. And that was counterintuitive because we thought we were the first that had a global credit scoring solution, but that was not the case. The data you can use globally. We enrich that with local data and we train local models, and that's how we keep it fresh. And we do everything together with our customers. That's how it works.
Good. I think I'm going to probably hold it there, but you win the prize for most questions so far. Thank you very much, Dietrich, and thank Dietrich. So we're going to, as I mentioned at the start of this session, going to switch now to an example of AI and how it's used within the government and regulatory and supervisory, whichever you want to call it, environment. And as I mentioned, I listened to a presentation by our next presenter, David Pereira from the Central Bank of Brazil, when we had the ICCR meeting last year. And I found it fascinating because I do think it's an area that there's a lot of learning to go on, and there's a lot of good benefit to be had. So I thought we'd give you both sides of the story. So David's going to now cover, I think, what's happening in Central Bank of Brazil. So I know it gets a bit technical, this one as well. So, and you are the last one before lunch, David. So no pressure, but please welcome David, and I'll pass it to you.
Hello, everybody. Good morning. First, I would like to thank Neil and the ICCR organization for the invitation to be here, speaking about our work, our ongoing work at Central Bank of Brazil regarding the use of AI technologies to boost our productivity. And second, I would like to apologize because maybe for most people, I think this presentation would be a bit technical. But I know that some of you, you don't have IT background, but you can ask me questions if you don't understand all the parts of my presentation. The title of my presentation is about our work in Central Bank, about the developing of a chatbot that is used by the internal users of our credit information system, which is the SCR. And first of all, let me introduce what is the SCR. The SCR is a public credit registry managed by Central Bank of Brazil. So it collects and stores detailed credit information, which is reported by financial institutions. And this data is used for monitoring credit risk in the financial system and for supporting regulatory and supervision decisions. And as you can see, we receive about 1.2 billion of credit operations by month, from which 144 million of these operations are from distinct individuals and 9 million of distinct companies. So this is a really big data system in Brazil. And besides serving our departments, this system is also used by financial institutions. So we have this role as a public credit bureau in Brazil. and we receive about 605 million credit reports by months from the financial institutions. So it's widely used by financial institutions in order to grant new credit. Which are the challenges that are faced by internal users of the central bank? This is the everyday challenges that we face. First, information fragmentation. SCR rules and guidance are spread across multiple documents, regulations, manuals, tutorials, and how-tos. So there are a lot of documents explaining operational aspects, regulatory aspects, and the information is widely spread along these different documents. So because of that, users struggle to locate and cross-reference information. And searching for specific information can be very, very time-consuming. And complex questions require understanding multiple sources. So our team, the SCR team, spends a long time helping our colleagues to find the right information about the system. One second challenge is the complexity of the SCR model, because we have a very huge database with many, many variables regarding the borrower, the loan. So our database schema is very large and complex with many tables and fields. And many times our documentation is incomplete or outdated. So we don't provide any official SQL training or practical examples for new data analysts. SQL is the standard language to extract information from our database. So the IT staff, they mainly use this SQL language to query information in our database. And finally, there is a very high risk of users, these technical users, writing incorrect SQL, leading to data misgeneration and data misinterpretation. The third challenge that we face there in central bank is that there are many requests, especially from senior management, about specific extraction, data extraction. So they often request, for example, credit risk indicators, for example, default rates, combining very specific variables. For example, combining a specific product with a specific region of gender and income. So there are many, these variables, we broke down the report in many variables. And these users, they usually lack the skills to query database or use the complex reporting tools that we provide to, especially for technical users. So because of that, they depend on our team for generating the data for them often, and they require prompt and quick support for us. So it's a burden for our team to help this kind of user. And how our chatbot, developing a chatbot can help these users. First, for this first group of users, which is the regulation and supervision analysts, it's good to help them as answering questions. So the proposed chatbot consolidates all the related information regarding our SCR system, and it should provide fast and accurate answers in the natural language, saving time and reducing support burden on our team. The second aspect, the second group, for the data analysts, this chatbot can help them generating SQL queries. So this chatbot translates the natural language queries into the correct syntax of the SQL command. and it helps these users to explore the SCR data model without any prior deep knowledge of the schema, of the database schema. So this helps, this chatbot can help them to reduce learning curve and preventing error in query formulation. And finally, for the managers group, this chatbot can perform the data extraction for them. So it generates and executes SQL queries based on natural language input, because it needs to understand the natural language, and it returns clean, ready-to-use Excel files for immediate use. So it can empower managers to access SCR information independently of our team. So we at Central Bank of Brazil, we developed a proof of concept, a pilot project, which is the development of an AI-powered question-answer assistant that delivers accurate context-based answers from two main sources of information. First, the SCR regulations and manuals, and the second is our database, our data warehouse database. And we built this chatbot using the modern AI tools and methods. So I just put the definitions because I'm gonna talk about these words later on this presentation. First, the heart, the most important component of our technical architecture is what we call the large language model, which we abbreviated as LLM. What is a large language model? It's a advanced model that was trained on a huge amount of text that understands and generates human language. And the big example is the ChatGPT that everybody knows and uses today. There's a very important technique that we used here when we was developing our chatbot, which is the prompt engineering. And everybody you use something about the prompt engineering to get the correct response. So it's basically it's a method to design the way that questions and instructions are given to the LLMs. And finally, this is the retrieval augmented generation. It's the basic architecture that modern chatbots use today. So to extract very specific information from a knowledge base, an enterprise knowledge base, we use this architecture. So it's a method that combines information retrieval with natural language generation to create more accurate and grounded response. And I'm gonna talk about this specific component later in this presentation. First, a brief overview. So our chatbot, our SCR bot receives a question from our internal users, and it can give two kinds of response. First, a text response, and depending on the question, it can generate data. So it's a big advantage of our bot that it not only provides a textual response, but it also provides Excel files with data. And which are the sources that the SCR bot use to generate this kind of response? First, it looks for the response using our repository of regulations and manuals. And the bot also gets the information from our SCR data warehouse, which is a very big data house with more than 13 years of credit data. Here I have one example of a conceptual question. For example, what is the document 34, which is the document that the financial institutions must submit to to the central bank? In this example, our bot can find this information in a PDF file, in a PDF regulation file, and answer. The document 3040 refers to data credit risk and must be submitted to central bank monthly. But the user can also makes this question: what was the default rate for vehicle financing broken down by financial institution, for example, in December 2024? So it's a very different kind of question. It's not a conceptual question, but it's really a data extraction question. And our bot knows how to answer this bot, and it generates an Excel file with the banks and the corresponding default rates for each bank in this financial product, which is the vehicle financing loans. This is a screen, a real screen of our bot. The question is in Portuguese, and the response, you can see there is a very complete, large response, where we gave the source of information. We have many manuals, many documents, and the bot knows where is the response for this specific question. So in this case, it's a PDF regulation, which is the case is the number 3869. This is another screen, but from the second question, this is the data extraction question. And we provided a response, and the robot knows how to interpret the numbers in an Excel file. It summarizes the numbers, give a very brief response, and for the complete Excel file, this bot provided a link to download the Excel file. And this is an important question. How does this bot works? How can it can retrieve information from the PDFs? First, this is the most time-consuming part of building a bot, which is the ingestion process of this information in the database. So we have a lot of files, regulations, and we need to store this information in what we call a vector database. I'm going to explain what is a vector database in the next slides. So let's detail a bit more about how this ingestion process works. First, we have the PDF with this regulation, and the first step of this process is to extract the text. And this is not so simple because sometimes we have tables, we have images, so we need to understand this in this part of the process and generate the corresponding text. After that, after extracting the text, we need to do what we define as the chunking process. We need to split this text in small chunks. In this example, for example, we decided to split in 3 chunks. And we need to decide which is the rule to split the text. And this is really important. This is one of the most important parts of our solution, is to decide how can we break this text in many chunks. And the main strategy that we adopted here was to split text by article. So each regulation there is a very there's a structure, a hierarchical structure, and the main section is an article of our regulation. So, given this, we could there in that example extract 3 pieces of information. But you are asking why we need to chunk, why we need to split this whole regulation in many parts. First, because it enhances performance and it's very cost effective. So small chunks allow faster response times and cheaper usage of LLM, for example, using the Open AI service to answer this question. It also reduces the hallucination risk. It's really difficult to deal with this problem. So small chunks minimize the chances of the LLM adding unrelated information or generating incorrect interpretations. And why did we chunk by an article? Because we preserved document structure and meaning. So each piece of text is self-contained, logically coherent unit. And because of that, because we chunked it by article, we could improve the retrieval accuracy of our bot. Because when chunks align with the document's structure, the chatbot can return more appropriate answers. Finally, the last step of our ingestion process, maybe it's a bit complicated to explain, because we need to call a service that we need to call embedding model. And in this case, we used the service that was provided by OpenAI. And so after submitting the text chunk to this model, what is the result? Each text chunk generates what we call a vector embedding. It's only a numerical vector. And what is this vector embedding? It's a high dimensional vector that represents the text, and most importantly, it captures synthetic, semantic, and positional meaning learned by this embedding model. So all of this intelligence is embedded in this model. And this vector has a very important feature, because texts with similar meanings generate vectors that have very small distance in our vector space. So this feature will be very useful in the next slide, where we need to find this information. We perform vector distance calculations. And finally, we have the text chunk, which was transformed in a vector embedding, and these vectors must be stored in our database. And there are many vendor choices, but for this proof of concept, we've chosen the Chroma, which is an open source vendor, very efficient. Let's deep in detail of our question answering process. Let's show the components, the agents that were created. So first, we have the question. So we have built what we called a router agent. This router agent decides if the user made a conceptual question or a data extraction question. And for that, we need to create a customized prompt. And we need to submit this prompt to the LLM. And the LLM is provided, we are using the service of OpenAI for this bot. And depending on the response of the LLM, this bot calls the RAG agent for the conceptual question. So this agent is can look for this information in our vector database, that look for the text chunks and generate this response, or the router can route the information flow to our database query agent. So this agent knows how to find, how to query information in our SCR data warehouse. And finally, it generates the Excel file representing the data that user asked for. Let's explain a bit more how this agent, the RAG agent, was built. So the question is the conceptual question, the definition about something of our system that the user needs to know. So we need to develop a customized prompt to be submitted to the LLM. How this process is done? This is the retrieval phase of this is the two-step, the retrieval step and the generation step of the agent. The first step, the generation, that question pass through the same step, through the same process of the text chunks that I've explained in the previous slide. So the question is converted to a numerical vector, the embedding vector, and we performed a similarity search using this vector, and we try to find in our database, in our vector database, similar vectors that can have the response for the user question. So the relevant chunks, the relevant text is extracted, and we provide this context to our customized prompt. So this whole phase is what we call the retrieval phase of our RAG architecture. So with the question, the original question from the user and the context that was retrieved from our vector database, we submit this prompt to the LLM that generates the response to the user. And this is the simple phase, which depends only on the service that we are calling. In this case, the OpenAI service. So this is the complete technical architecture of this component of our chatbot. Let's explain a bit more how the similarity search works. So we have that original question, and we embed this question, which converts this embedding process, the question into a vector question. And with this vector question, we perform a similar search on our database, which is basically a distance search. In this example, we have only four vectors, 4 text chunks stored in our database. For example, the first vector, the distance between the question vector and this vector is very close. So it means that that information could be relevant for our response. So we get this information. We get the correspondent chunk, which in this case is chunk 1. So chunk 1 is the piece of text. 34 is the credit data file, etc. So it has a chunk there. The second is not related because the distance between these vectors is very far. Third is also very far. And finally, the fourth vector, the distance between our question vector and this vector is close. So we need to consider the corresponding text in our prompt. So we get chunk 1 and chunk 4. And these two chunks must be added to the customized prompt. So this is the context. This is the internal context that only can be retrieved from our database. The original ChatGPT, it doesn't have this kind of content that we could extract in this step. So this is a code snippet of our original prompt. So we instruct the OpenAI. You are an expert in SCR. You use the following information to answer the question clearly, objectively, and assertively. You only use the facts from the provided context. So it's there, in the bold text, that we insert the text that was retrieved in the previous step. And if the answer is not presented, respond that you do not have that information. And we provide this complete prompt to the LLM reply this question. If the question is a data extract question, we also need to create a customized prompt. But in this case, we need to get IT information from our IT department on how is the database built. So we need to get information about the tables, the columns, the join between the tables. So with this information, the question, and also the database specification, we submit this customized prompt to the LLM. And the result of this is the SQL query. So this is almost done. We have the query to use in our database. In this case, we give as an input to a query engine. This query engines use the SQL query and extracts the information from our SCR data warehouse, and this engine knows how to create the Excel file, the resulting Excel file for the user. This is an example of our customized prompt, which we have the question and database specification. So it says, you're an agent that generates SQL queries for Teradata, which is our vendor, from natural language. We have provided some basic rules. For example, generate simple SQL with few relationships. If the user does not provide the reference date, reply only. I can't generate this SQL. And there are many rules like that. We have also the table definitions, the name of the tables, the columns, the type of the columns, and a brief text explaining the meaning of each column. And finally, we have the relationships between the tables to help the LLM build the final SQL. And with this customized prompt, the magic happens. It's incredible how the LLM can generate correctly the SQL command. In this case, for the question that I have introduced, what was the default rate for vehicle financing? Our engine, our agent, it generates it's a fairly complex SQL comment, as you can see. There are some calculations to find out the default rate. There is a table join, so it's complicated, but you can learn a lot. As I have explained it, a new data analyst can learn from these generated comments. And finally, the next steps of our work. We are planning to deploy the AI models in our premises cloud. So what does it mean? We need to migrate from external API calls, which is in case is the OpenAI call, to internally hosted models. So with this migration, we address privacy concerns with sensitive documents and reduce response time. And a second work that we need to do is to improve our ingestion pipelines. We need to create text extraction and chunking processes for our internal intranet pages, which so we need to create an ingestion process that knows how to extract text from HTML pages. And finally, we need to test different chunking size and split rules. I have said this is an important part of our process. And if we improve this, we are improving the retrieval accuracy of our bot. And last, but we need to evaluate other vendors, especially open source LLMs. We have many alternatives, like, for example, Llama, which is a LLM model provided by Meta. And we need to reduce dependency on commercial providers and enable greater control and customization of our solution. This was my presentation. Thank you.
A lot in that, a lot of detail, which just goes to show how much the central bank is spending time and effort in implementing AI. So hopefully there were some takeaways for that. Any questions from the audience? Elias?
Hello. Hello, Davi. Just curiosity, how many tokens you use on the question? How many tokens maximum that you provide as an answer?
In the chunking process, we need to limit
that's my question.
because if it's too large, there's a problem because it can return, the chatbot can return a very strange response with many related text. So we are limiting to 1,000 tokens.
Okay.
And we are considering the most 5 important tokens, because the first step is the similarity search. So we configure how many chunks we need. We can have 5, 10, 100, but the more tokens that we work with, more complicated is to generate accurate response. So we are working with five chunks in each question request. And each response, we also limit the response, the number of tokens, because there is a cost. It's very, it's not cheap to use this kind of service. So it's we are also trying to migrate to an open source solution, because but there is a big solution, upfront cost, because we need to have this infrastructure in our premises. And we know that we need to buy GPU infrastructure, and it's very, very costly to build this kind of infrastructure internally. And we are in the initial phase of our proof of concept, and we are spending like hundreds of dollars per month. It's not so much for a central bank, but there's just a few users using. We didn't launch this solution yet to the whole bank.
Okay, thank you. And one more question, if I may. Dietrich, I'm going to take the one in front here, if I may. Dietrich,
Hello,
maybe you could pick it up with...
I'm Louis from the Bangko Sentral ng Pilipinas. My question is, what happens when there are unclear questions? such as when the person who posted the question used, let's say, a terminology that is not yet in the database?
So it's about,
Does the chatbot rejects that question, or it still responds but with also a vague?
Yes,
Our
this is really a good question. We are trying to deal with this problem, refining our prompt, and we've seen that many questions. It's for us, it's very easily to understand, but the chatbot doesn't understand, and it's a trial and error process. We learn from the response how to improve our prompts, and this has a side effect because the prompts are getting each time bigger because we are inserting more rules. If the user says that, do that. If the user says that, so we need to and it's more costly. The bigger the prompt, we need to pay more money to OpenAI. But this is really a trial and error. We are trying to refine this to always answer the most accurate question, response. And something that we need to do is to instruct the LLM to say, if you don't know the question, don't create answers, because it happens a lot. So we need to give many rules. If you say you don't know, if you are in doubt, if you don't answer, because it happens a lot. The hallucinations, they happen a lot. So we are trying to deal with this problem.
Okay. I'm running out of time and running into lunch, so I'm going to probably ask if you've got any other questions. Maybe you can speak to David over lunch or the rest of the afternoon. But very comprehensive presentation, David. Thank you very much. Thank you for coming. David's actually on.